Thank you very much. I'm glad you're caffeinated. I will want to take you on an expedition. We had already Neil going to the Antarctic, and the Amundsen flew the first one to the North Pole, and Armstrong and Aldrin the first flew to the moon, and now I want to take you to an even larger expedition. I call it Terra Incognita. It's the knowledge desert. And the purpose of the presentation is to give you some tools, if possible, to help us navigate on this expedition and also hopefully be able to build some consensus and find ways how to deal with the psychological challenges of the human species. So many of us here have this sense that somehow the quantity of the human enterprise has become too large? Or is it only a quality problem? Climate change, the amount of carbon left to emit, if you want to stay within 2 degrees Celsius, would point to its quantity. But how much really? And to what extent does it matter? Does it matter to use more than the planet can replenish? And here we may think yes, but the interesting point is that the opinions diverge very greatly. As an example, I don't know if you have heard about the runway expansion of the Vienna airport. They want to build a third runway that would double the flight traffic by 2030, and so they had to do an environmental impact study. And normally they just look at frogs or chickens that need to be moved, but in this case they said, wow, this is not consistent with Austria's commitment to Paris. And it got contested in the court, and the court said, yes, indeed, it's not consistent with the Paris Agreement. And that produced a huge uproar. And the interesting thing is that unisono, the business community thought it was the most strange decision because it would put at risk the competitiveness of Vienna. While you could also make the case that actually not building the runway in the context of climate change would be an economic protection for Vienna, because if they start to build stranded assets like bigger airports and all the hotels around it and the conference centers around it, that would be a cost to society if they invest in something that cannot be used. So that's basically what we see, very distinct views about to what extent resource security is essential for our long-term benefit or not. And in between is this famous terra incognita, because both sides think they have knowledge about the same piece, but knowledge as inconsistent, even non-overlapping, in my view, is not knowledge. So that's the knowledge we need to find, and we need to build a bridge between these two very distinct viewpoints. And that will be the focus today. And how can we explore that? We explore it through two parts. One is to have metrics to first understand how much nature do we have, how much do we use. That will be the first part of my presentation. And then the question is, does it matter? With those questions, I went to a class of 10-year-olds, and I said, so how would you measure nature? A girl immediately put up her hand and said, square miles. I said, wow, that's great. Took us a few years to find that out. Now, why would we need to know how much nature we use compared to how much there is? Same girl put up her hand and said, if we use more than what nature can give, the only thing left to eat is imaginary cookies. And so I was quite taken back how you could have that insight. Of course, it's slightly wrong because we can store cookie dough in the fridge for some time. And so continue to eat some cookies, but there's also some truth to it, obviously. So how can we explore first how much nature we do have and how much we use? Oops. And I would like to kind of go through an iteration of understanding how we can measure this. So first, we need to establish whether the question is actually researchable. Can we translate into a research question that we can answer? Can we produce an answer to this question? And then is the question really good enough to use? It would be better just not to use it. Now, the basic principle we start from in order to find out whether we can measure nature is to recognize that life is wonderful. It's also very cooperative. And at the same time, also, it competes. It competes for ecologically productive space. That means the area used for my potato cannot be used for your potato. It cannot be used for the horse that wants to graze. So some uses, they compete for ecological productive space. And because of that, it's possible mathematically to add up these spaces to a whole, to a sum total. And that sum total is the area that is needed to maintain my metabolism. And that's what we call the ecological footprint. So we add up all the competing demands on nature into one area. And we compete for like urban space, because if you pave something down, like here, potatoes don't grow very well anymore. We grow food. We also need capacity to sequester CO2 if we want to continue to burn fossil fuel. So all these areas are in mutual competition and add up. Now, we can compare that, like with every good accounting. You look at both sides. How much do you use? How much do we have? With what we would call biocapacity. So that's the area of the planet that can provide renewal. And we would even call it the ultimate resource. Because what limits the human enterprise is not so much the fossil fuel, for example. We found out that there's too much fossil fuel underground. What limits the fossil fuel use is how much we can burn and the biosphere can absorb. We're also not limited, I would say, by rare metals as much, because with more energy we can dig deeper and find them, so it takes more effort. Again, we don't have the fossil fuel for it, but ultimately somehow we have to find the energy to do it in a way that doesn't compromise biocapacity. So ultimately, biocapacity is the limiting factor, the ultimate farm on which we depend. Now, I would say when we developed the idea of ecological footprint accounting, really it's much more a discovery rather than an invention. In the same way, like when an apple fell on Newton's head, it was not an invention of gravity, it was just a recognition, because many have known about this before, perhaps the Romans even. I just was here in Rome to see it, but for sure all the farmers understand that there's a relationship between how many cows they can put on a pasture, or how much crop they can get from a field, etc. So it's nothing new. It's just a way to kind of explain our economies from a farmer's perspective. So again, just to summarize, there are these two sides. One is how much nature do we have? How much nature do we use? How much we have, we call biocapacity, roughly called the supply. How much do we use is called the demand. The footprint. Now there's one innovation that we added to just saying land is mutually exclusive, or we can add exclusive areas together, is to recognize that not every piece of surface area has the same inherent productivity. So like currencies, when we want to compare them, we translate them into one common currency, like dollars or euros, for example. We use as a common currency global hectares. That's an average productive hectare, so we can map every hectare of its productivity to a global average. And so we can compare them across the world and also across time. And when we look at how much is available, if you take FAO data and what's the productive area on the planet, for the oceans we look at the exclusive economic zones and all the productive areas on the land. We divide it by number of people today. What we get is 1.7 global hectares today. That's the budget available per person. When we then apply this thinking and say, like, how does the world operate? And we look at every country as if it was a farm. This is the map around the time I was born. The darker red, the higher the ratio between what the country consumes as compared to what the ecosystem this country can renew. So the United States just turned pinkish, has a very large biocapacity per person, but also already back then had a very high consumption. And then in the last, over my lifetime, we had a vast transformation that by now about 85% of the world population live in countries where the metabolism is larger than what the ecosystems can renew. How is that possible? Of course, we can use more, like it's not with the cookies because we have dough in the fridge. There is some stock that we can deplete. We can use the atmosphere as a sink for some time and fill up that sink. We can overuse fish stock, we can overuse forests, etc. So it is possible for some time to use more than what we have. And our estimates currently is roughly that humanity's demand overall adds up to about 1.6-fold what ecosystems can renew at the current rate. So if you look at that over time, the biocapacity of the Earth has not been static, thanks to agricultural advances, some of them also more inputs, but also better management to some extent. Overall, we still see an increase of ecological productivity on the planet. As a mechanistic view, just how much can we squeeze out of the planet, yet human demand has grown even more rapidly. We can also see some historic events. For example, the 2007 financial crisis shows up as a little dip. I think here you can see that on the graph yourself. To communicate that, so what does that mean compared to biodiversity? Of course, should we use the entire biocapacity of the planet? So that's a question we need to ask ourselves. E.O. Wilson came up with his new book. He says half Earth. He would love to leave half of the space for other species. If that's so, then the green line that we can use for ourselves would be even lower compared to the red line. That just shows kind of the level of difference between the human metabolism and what, for example, E.O. Wilson thinks would be a healthy metabolism for humanity. To communicate this difference, what we do is every year we translate this ratio between how much we use compared to how much we have in a date. And last year it was August 8th. That meant by between January 1st and August 8th, humanity used as much as Earth was able to renew using FAO statistics. Maybe an underestimate, but that's what we conclude. We call it Earth Overshoot Day, and from this year on, we actually will call it Move the Date. So it's not just to mark that we have used, but how could we actually shift that date? If we move the date 4 days every year in the right direction, we'd be back to one planet by 2050. So 4 days, not that much. It's totally feasible, just we haven't put that much effort. Last year, we got about 1.8 billion media impressions. That means people who could have seen this news on their media platforms. So it's kind of gaining momentum. And it's interesting to see how ministers start off in their presentation. They say, oh, did you know about August 8th? Of course, the cake, this wonderful wedding cake of the global footprint, humanity's footprint, has different layers. The top layer in blue is what it takes to absorb the extra CO2. We put very little biocapacity aside for absorbing CO2. Some we do. We prefer carrots over carbon sequestration, so there's this competition. We also see a still slight increase of crop and fishing and forest products growing up. But we have been able to contain it largely also because we use more and more fossil fuels. I'd like to remind you that the blue part, 100 or for sure 150 years ago, you couldn't have seen. And if we follow Paris, the blue part should be back to zero before 2050. So how can we do that? As Tim said yesterday as well, how can we do that without pushing the pressure on the rest of the biosphere? That's a big challenge. Totally possible. Technologies exist, like for example photovoltaic energy generation. Just the trends have not shifted yet at the pace we want to see. The big question is, how good is the answer? We use strictly FAO data, not because it's the base data, but we want to put the responsibility of the data onto the nations. We just aggregate that information. We use about 6,000 data points per country and year, and so we can calculate a time series from 1961 when the UN started to be more consistent with their data up till today. And then, of course, it's publicly published, but then we also had about 10 nations to review our data and kind of see can they recalculate it. Like, for example, the French, they on their own recalculated the time series for France, and they got it within a 1 to 3% replication. They still didn't adopt the footprint, but at least they kind of recognized, yeah, the numbers are about right. We also need to recognize it doesn't answer all questions, it just answers in a quantitative sense how much do we use compared to how much we have? And quality matters. Just what we say is that you cannot meet quality if you don't meet quantity. We can have quality in some parts at the expense of other places. For example, Switzerland introduced to de-intensify agriculture because they subsidized cows, now they subsidize landscapes. So that's better for the ecosystems in Switzerland, but as a consequence, because the Swiss continue to consume at the same rate of cheese and meat, now more comes from Brazil, so Brazilian beef, Brazilian soybeans, so the net biodiversity impact of that Swiss policy may be net negative, even though in Switzerland, the alpine meadows have more flowers. So, of course, also we improve the data. So it's not just that data improves even historically. The UN updates its numbers historically even, not just the latest data point. So we can sharpen the question every year. The biggest change that we have made is that that people believe that our sequestration analysis was not adequate. So we reviewed it and found that actually, according to the newest data, as IPCC publishes it, the average sequestration of forests around the world is about 20% lower than what we estimated. So it hasn't gone lower, it just kind of, the data has become better. So that means the carbon side of the footprint has gotten larger. People ask us, how long can we be in overshoot? And it's a difficult question to answer because every ecosystem reacts differently. But one of the big parts of the ecological footprint is carbon, and now as we've defined 2 degrees Celsius as the limiting factor, then you can translate that into carbon budget left. It's pretty straightforward. Most models say for 50 ppm would be the maximum for 2 degrees Celsius. We are already are at 405 just in carbon. If we include non-carbon CO2, non-carbon greenhouse gases, we may be already much beyond 450 today. So that gives us a sense of there's not that much extra left to be in overshoot while still maintaining the stability of the ecosystems as we know them. So there's the link between stocks and flows. But so the footprint just does flow accounting. I want to show you how different the various nations react. I think one of the big misconceptions is that we're all on this common slippery slope. But actually every boat is very different. We are in a common storm, but with very different boats. Here are some Asian examples. Vietnam is interesting, how they it's one of the few countries on a per capita basis changed its biocapacity, largely because of changed agricultural productivity, and they got so economically active that the footprint grew even more rapidly. But it just shows all the trends are not destiny. You can actually manage them if you want. Here, Latin America, Central America, very different from South America. South America, incredibly rich in biocapacity, but still losing it largely because with larger populations, you see these trends of declining biocapacity per person. Central America, in a very tight situation. Even Costa Rica has now entered a biocapacity deficit in spite of all their good efforts, but still you can see the situation. El Salvador in a much more difficult spot. What the accounting allows is then you look backwards. It's not speculation about the future. You can just track the history of what has happened. You can start to peel apart the various factors that drive the situation. And here, just as one example, I looked at the world. How has the per capita footprint changed? How has the population changed over the last 50 years? And what we see is that the net demand on nature per person, so in global hectares, has moved from about 2.3 global hectares per person to 2.7. So it's a slight increase, but the population has moved from 3 billion to 7 billion. So a much more rapid increase there. The next slide is a bit of a tragic slide. It looks at the lowest income countries, or the ones that were classified lowest income in 2012, and then looking backwards how they have moved. We see a nearly quadrupling of the population, and because of that pressure, the tragic then outcome, I mean, I wouldn't, perhaps it's not a causation, but it's happening at the same time that their ecological footprint is at a very low level. It's at less than half of what the world average is. It's a very tight ecological footprint, has overall been declining. It's now recuperating a little bit, but on still a very, very tight spot. So let me now get to the second part of saying yes, we can measure, and you can ask, is that a good measure or not? We think it's a bottom line measure. It doesn't address quality, as I said. It's just kind of sheer quantity. Where are we? Now, does it matter? And I think that's the very difficult question, and many people in here have struggled with it. How do we translate that in something that the urbanites, decision makers, resonate with and see, wow, yeah, that actually is a risk. It's something we need to address. And I would like to start first with one perspective, that to say, how can we use monetization? And I think there have been very great efforts until, particularly like with TEEB, or what Gretchen Daly has done, and Partha Dasgupta, on how can we translate things into units that economic decision makers can understand. And at the same time, it also shows kind of the tension between the various worldviews. For example, the World Bank produced a report in 2011 called Changing Wealth of Changing Wealth of Nations, where they came to the conclusion that when they looked at the entire wealth of the world, the intangible capital, that's probably the social and human capital, is about 77% of the total capital. The produced capital, so it's kind of the built capital, would be 18%, and the natural capital about 5%. And then for me, more from a space engineer, I would say, if you were in a spaceship, and the spaceship would be kind of tight with oxygen, you use your resources 60% faster than what the spaceship can renew, and you had a choice of saying, you can either get, let's say you're with 100 astronauts on this spaceship, you can say, okay, you can get 6 more astronauts, or you can get a third more kind of furniture and equipment, or you can get an entire new spaceship. Which one would you choose? Probably, I would say, a spaceship. So in some ways, I think if you look at the monetary value of the whole, it becomes very difficult to make a strong argument that natural capital really matters. It seems like, wow, it's very cheap. So in financial reality, it is very cheap. But if you look at it from an absolute perspective, you run into this diamond-water dilemma that the economists kind of discovered and were puzzled about. Why are diamonds more expensive than water when water is more essential to life? And so that the marginal assessment, like the effort to get the next diamond, is much harder than the effort to get the next amount of water. But if you extend that to the absolute, it becomes very difficult to make a strong argument why natural capital is important. So it is a difficult way how to do that. Let me try to look at a different way of making the argument, going back to the map that I showed you earlier. Basically saying there are different types of countries. We call them countries with ecological reserves, or countries with ecological deficit. Why can countries run ecological deficits? For 3 reasons. One is because they can net import, for example, food. They can use the global commons, like international fisheries, or emitting CO2 to the global atmosphere. And the third thing is they can overuse their own ecosystems. Globally, obviously, only the third option is possible because we don't trade with other planets, so that then becomes automatically overused at the global level. But for nations, it can be one of the 3. So we can make a diagram showing where are the countries in terms of the ecological reserve, where are they in terms of ecological deficit. Switzerland, where I come from, uses about 4 times more than what its ecosystems can renew. 4 times. Egypt uses 3 times more, but at a much lower level. And you can ask yourself, which country is more at risk from a resource perspective? And I would say Egypt, because Switzerland has a high income, so it can use its income to get the resources more easily from other places than Egypt. So what we do, therefore, is we use as a second axis, we use income as a way to place countries on this diagram. And we distinguish countries between which ones have an income higher than world income, which ones have one that is lower on a per capita basis than world income. On the basic, it's perhaps a very mechanistic engineering insight to say if you have less than world average income, more likely than not, people can buy more from you than you can buy from them, or vice versa. If you have more than world average, more likely than not, you can buy more from the others than they can buy from you. So how does it look like then? How are the countries distributed? So we can see that the green spot would be the area where you have the double positive. You have high income and you have a lot of resources. That makes it most cozy. And the red spot makes it most difficult. You don't have financial and you don't have ecological assets. So this is a rough distribution of countries where they are located. And then if you look at it just kind of from a distribution, is to say, wow, 71% of the world population now lives in countries that both have an ecological deficit and at the same time less than world average income. And the world distribution overall is 15% are in the lower gray field, etc. In economic literature, there's a lot of discussion about the resource curse. But still interestingly, if you look at the ratio between high income and lower income of countries with ecological deficits versus those with ecological reserves, it seems much more favorable in countries with ecological reserves. So I don't discount the resource curse, interesting conversation. I think it's more a governance issue. It's more around concentrated resources, but around biological resources, it doesn't seem to be the case. It's not a proof, it's just something we should investigate a bit further. Now, what can we conclude from this one? If we truly see that as a threat, then we should question, then we should question our current attempt of saying, let's end poverty through expanding incomes. Because if we just blindly expand incomes and typically do that through using more resources, the average trend follows that arrow. And not only that, if we all doubled our income, the line of average would also double. So you still would, in relative terms, not be able to get more from the others than they're able to get from you. So as we compete for the surface of the planet, that wouldn't work out. So that, from my perspective, would say what we really need to do if we want to have people with better lives and also higher incomes, if that's important, we need to do it via building resource security. And that's why I'm so thrilled that Charles was talking about it, and as well, that's the significance for development to build on resource security as the driver. Not as a conditionality, not something nice to paint on to the development project, but really it's the essence that makes it possible to sustain income. Another way of looking at it is the following. I'm showing you the same graph again of the loss of my life, basically, of ecological demand and ecological supply. I don't know how it will continue, but let's assume that we just continue straight, that we are able to continue to increase biological productivity on the planet through agricultural advances particularly, but we continue also to increase our demand. What I want to point out is that the burden we put on the planet is not so much the difference between the two lines, it's the accumulation of the deficit into an overall debt. And that's the depletion of the cookie dough in the fridge, so to say. Now we can overlay that with our infrastructure. Infrastructure has a very long lifetime. People have a very long lifetime. So we lock ourselves into a situation for the future. We lock ourselves into wonderful investments, or we lock ourselves into bad investment, depending on how we do them. And I think that's kind of the lens where we suddenly can see that if we address also climate change more aggressively through the adaptation lens, we may get more mitigation benefits. The reason is the following. Even if we got all the fossil fuel for free, if there was no cost and the emissions were no cost, we would build up a lot of infrastructure that is heavily dependent on that fossil fuel. And then if the day comes where that's not anymore possible, we are stuck for our entire economic machinery with money-making machines that can otherwise not be fed anymore. So they become stranded assets. So even if there was no cost in carbon, even if fossil fuel was free, investing in those aspects, like the third runway in Vienna, could become a very dangerous economic development policy, even though the costs don't show it now, apparently. So that's another way of kind of linking the metrics of saying of overuse, a physical view, to saying how does it translate into economic risks. So what's the conclusion? I think if I could make one proposition to the Academy here is perhaps how we can talk about resources in a way that may find more resonance around the world. And I would say rather than saying it's a 0-0 game, or a zero-sum game where just elephants versus poor, or it's just kind of, oh, we can have win-wins, no problem, don't worry. In the end, if you can celebrate the environment or resource security as the enabler of development, and say, if we truly want to end poverty, if we want to have a business plan that ends poverty, which we want, it needs to have resource security at the center, because the lowest income people, they cannot buy themselves out of the squeeze. That's the bottom line. If we really believe that, it's absolutely possible to shift the trends. Very simply, with every decision that we make, we have to make sure we increase resource security, and we have to do it in a way that also produces financial gain, because if not, it's not replicable. And there are some projects that will not increase resource security, and they're still important. Like vaccination is infinitely important, very cost effective. We should do that. That just means we need to be even harder on the other programs to provide, deliver more resource security. Let me expand a little bit. When I look at the way we hold public policy today, to me it translates into a losing last strategy. I had the fortune to have a lunch with a high official in the US administration some years ago. We were allowed to ask some questions. I asked her, how do you see the future of Pakistan? And people were kicking me under the table. How can he ask that? And she was very honest. It was very interesting, actually. She said, I don't see a positive future. And I was somehow impressed by the honesty and also shocked, because if you have a friend and you see they're in trouble, why wouldn't you go to them and say, let's close the door, I want to talk with you. What would it really take for you to win? Like, I don't see a future. What's your plan? And so we just kind of think, oh yeah, if Pakistan goes before and then Egypt and then, and then in the end me, so I'm fine. I'm losing last. But it's still a losing strategy. So how can we turn the losing strategy in a winning strategy? And so it sounds simplistic perhaps, but I think it starts with committing to your own success. To say, actually, losing last is not the option. What would it take to succeed? And as we recognize in Spaceship Earth, my success depends on your success as well. And that's why I think the search for the terra incognita to actually find this, to close this knowledge gap. It's not even a knowledge gap, because people are so adamant about they already have the knowledge, just that it doesn't overlap. I think it's absolutely central to also build the consensus for public action. If that terra incognita helps us recognize that resource security is really essential. And for example, in my country, in Switzerland, the Ministry of Finance doesn't think so. We had a vote about the ecological footprint just 3 months ago. There's a lot of referendums in Switzerland, and the Swiss government, or was asked, like by the population, to say, we want to have a vote to have a green economy by 2050. What does a green economy mean? We want to live by 2050 in a way that would fit on one planet if everybody did what the Swiss did. Currently, it takes 3 planets if everybody lives like the Swiss. So let's have a green economy to get to one planet. The government said, it's a great idea, but it's too fast. It's a great idea, but it's not possible to live on one planet. They actually wrote us to say, can you please send us references, academic references, to make the case that it's possible to live on one planet. And the interesting thing was that my colleagues actually tried to start to answer the question. And I said, no, we need to write them back and say, please send me reference to show how it's possible to live on 3 planets. You have the burden of proof, not us. But anyhow, so at least 36% of the Swiss population said it may be a good idea to live on one planet. That's great. And I don't know what the others thought, because if you go to a birthday party with 4 people and there's 1 cake, and you say, I'm Swiss, I need 3 times more than average because I'm quite modest. And so you take 3 times a quarter of the cake, because that's 3 times more than average. And then the other 3, they can each have a third of the last quarter. So essentially, for every Swiss that says, we need to have 3 planets, 3 times more than average, we need to find 3 others who said, oh, happily, I'll be on like 9 times less. They apparently know how to live on 9 times less, not just on the average. So it asks mathematical questions about how will Switzerland be able to function? Because Switzerland's relative income
is vanishing because China and Brazil is growing much more rapidly. How will Switzerland be able to secure its resources in the long run? Is that really a stable function? So therefore, I think it's important to measure what we treasure. But do we treasure resource security? That's what we need to find out first. So then we can actually find out, are we moving at speed and scale to where you need to get? Because in the end, it's not just about being nice, it's about, are we committing to our success? Do we want to have a good life? And it's possible. So thank you so much for your attention. I hope this tool will help you to navigate, and I look forward to your questions. Thank you so much.